Hello guys, so we're going to be continuing on our series on recursion, right? And I'm just going to be going through recursion problems and building that mental mapping of how recursion problems are going to be solved by looking at them and seeing how, just building my mental muscle around that. So let's see, what we're trying to do here is count occurrence, and basically we're trying to see how many times a variable occurs within a string, right? And for that reason, okay, I had this right up. The thinking behind this is that I have seen it already so many times. This is more like an epistle by me. Don't think it's greatly necessary. It's basically my thinking at the time. But I think something that stands out is this line 6 that says, "But I can't shake the feeling of an optimization on the horizon. It is." So basically, it's after finding out that I now came and wrote that it's for the iterative implementation. Basically, when I saw the implementation, I think when I saw the problem, I had a glimpse or like a clear idea of how to solve the problem. But even after seeing that, I was like, this something feels off about this, and yeah, I just intuitively said, um, there's an optimization on the horizon. Those are salient, but it is what it is, and we are going to get to that between the two episodes that we're going to just have for count occurrence. So for the initial stage, basically the recursive implementation, we take in the string, the value, a count, and an index. But the stuff is that what we do is that we initialize the count, so it's not necessary for us to pass it in when we are calling the function, and also the index, because these are just helper variables for us. So as we started with, we said the base case. Obviously, the base case is the case or is the instance that we watch out for to stop the loop of the recursion, basically. So yeah, so we define our base case and we say when the length of the string is equal to the index, return the count. So basically, what we're saying is that when our iteration or the length of the string is now gets to the index that we are increasing as we go, basically let's stop. That means we have gotten to the length of the list, right? And we could see that that immediately tells us that obviously our index has to be incremental, right? And then we say if the string at that index, basically at the index of 0, is equal to a value which is the value of a, or whatever the value we are trying to check whether it exists in the string, an amount of times, let us increase the count of that value, or the count of our count variable, making it that this value is in this string, and yeah, we found one in a sense, right? And I'm going to explain that from the line 7 down that we just have, and we kind of see that we call a banana string, and then we are asking the amount of a's within it, right? I think I should have started off with this. But yeah, there is that. And basically what we've done so far is that we've said, oh, if the length of the index is equal to the length of the banana string, let's return the count value, and yeah, basically break the chain. And then basically here we say that if the string at the index of, or the index we are at, is equals to value, which is equals to a, we want to increase the count of a plus 1, and then we call our recursive case where we now return the count occurrence again, but this time around we call the same string, we call the value, we pass in the count, and we also go ahead to increase the index. So if we are operating at the index of b, we are now moved on to the index of a. So this next recursive call will not focus on any other thing except from the index of a. So when we call that count occurrence and we pass in the two values, we get what we should get, which is 3, and basically that's it. So subsequently, we're going to get into the iterative count occurrence and see how it gets how the optimization comes alive and how my intuition was on the spot. Bon voyage, auf Wiedersehen, tschüss, bye.